In the previous lecture, we have defined a couple movement, and with in this definition, we can now represent a force F applied on a body E provided at a point as a sum of force on the bride and couple acting on it. This is shown in figure 1. Thus, the bar R is showing in figure 1 is in equilibrium. The bride must be applying force minus F and a counter couple movement on it. To see the equivalent, let us take the example above and add a zero force to a system at a bride point. This does not really change the force applied on a system. However, the tricks to take this to zero force and be a made up force F and minus F as shown in figure 2. Now the original force F and minus F at the period suspended at a distance d, therefore form a couple movement of magnitude Rd. In the addition, there is a force F on the body at the bride point. The combination is therefore the force F is bride at the point P and couple moment tau Ft. Notice that I am not saying tau about the bride. This is because the couple is a free vector and its effect the same no matter at which point is specified. Example. Well, here it is examples. Well, you must have seen a gear shift handle held in old bases in zigzag shape. Let it be the shape shown in figure 3. 3.60 cm at angle of 45 f of axis s axis, 30 cm parallel to x axis, and then 30 cm again to 45 degree from the x axis to xy plane in shown and in the figure 3. To change the drive, applies the equivalent force F minus 5j plus 5j. F equals to minus 5I plus 5j minus 2k Newton on the head of the handle. We want to know what is the equivalent force and the moment that bottom, therefore the original handle for this original handle shown in the figure. For this again we can apply zero force. F and minus F which cancel each other and at the bottom of the original force and the minus F given a couple movement. Then tau equals to R into F, where R is 60 under root 2I plus 60 by under root 2j plus 30 I plus 30 by root 2I plus 30 by root 2j into minus 5I plus 5j minus 2k. 90 plus 30 under root 2 divided by root 2I plus 90 by root 2j into 5 root I 5I minus 5I plus 5j minus 2k equals to 450 plus 150 root 2 divided by root 2 k plus 180 plus 60 root 2 divided by root 2j plus 450 by root 2 into k minus s 90 root 2 I. Thus the equivalent force of the system F is minus s 5I plus 5j minus 2k Newton. At the bottom of the couple equals to 90 under root 2 I plus 90 under root 2 plus 60 j plus 600 under root 2 k Newton per meter. Having obtained the equivalent force of the system, next we wish to discuss what kind of force and the movement do different on the element of using the engineering mechanics apply to other elements.